imbecile. What is this? Paper. Park? 5 o'clock. It's almost time.
Hey, I need your help.
Sure, what can I help you with?
I'm doing a project for school.
So what do you need to do?
I have to roll a basketball off an inclined plane and have it fall into a hoop.
Oh, that's easy. You just need to derive some equations. I'll show you how. Okay, so this is an inclined plane / projectile motion problem. If we know the angle of the incline and the distance the ball rolls before it falls, we can calculate the acceleration of the ball going down the incline and its initial horizontal velocity. The acceleration will be equal to g sine theta, where g is gravity, 9.8 meters per second squared, and theta can be determined by knowing this height and this length. Since Vf squared equals Vi squared plus 2AD, and the initial velocity is 0, Vf squared is equal to 2AD, and Vf is the square root of 2AD. And if we plug in A as g sine theta, the equation is equal to the square root of 2g sine theta d. The distance at which the hoop needs to be placed can be derived from the equation d equals vt. The horizontal velocity is the velocity we calculated from here to the square root of 2g sine theta d. And the time is the time it takes to fall from the edge of the roof to the height of the basketball hoop. Then using the equation d equals vit plus 1/2 at squared, since v is 0, we can simplify the equation and derive the equation to solve for t, and t equals the square root of 2h over g. Therefore, the final equation for the distance the basketball hoop needs to be placed from the edge of the house is d equals the square root of 2g sine theta d times the square root of 2h over g. This can be simplified to the square root of 2g sine theta d times 2h over g. The g's cancel out and the 2's come out front. So then d equals 2 times the square root of sine theta dh.
So all the necessary measurements were taken with a tape measure in inches and then converted into meters. The height of the incline was 1.617 meters and the base was 3.96 meters. Therefore, the ramp length is 4.28 meters after using the Pythagorean theorem, which is the d. Then, by using the equation inverse tan of opposite over adjacent, that is equal to theta. And theta, by plugging in the numbers, is equal to 22.2 degrees. Then, by measuring the height of the incline from the ground and subtracting the height of the basketball hoop, the h is found. The height of the incline from the ground is 5.33 meters, and the height of the hoop is 2.9 meters. So that means the h is equal to 2.43 meters. Finally, by plugging in the numbers in the equation, the distance of the hoop is 3.965 meters.
It's 5 o'clock. Where is she?
Man, he's not gonna see this coming.